Hello friends. So now after completing the question number 2, let's start with the question number 3, which is based on implicit function. So here I have taken one implicit function, or in the question they have given the implicit function and we have to prove the result. But guys, the result is very big. So let's understand this, how we are getting the answer. And let me tell you one more thing, that this question is very important from exam point of view because it has many concepts involved in that. So pay attention carefully and understand that problem properly. So here it is given that x square upon a square plus u plus y square upon b square plus u plus z square upon c square plus u is equal to 1, and we have to prove that del u by del x the whole square, del u by del y the whole square plus del u by del z the whole square is equal to 2 times x del u by del x plus y del u by del y plus z del u by del z. Now guys, as per the result, it is clear that u is a function of x, y and z. So if u is a function of x, y, z, if you observe this given equation, then this is an equation of x, y, z and u. So there are 4 variables. Out of that, the 4th variable, which is u, is a function of other 3 variables, that is x, y and z. And if I take this 1 on the left hand side, it will become -1, and on right hand side will get 0. It means it clearly shows the form of implicit function. So guys, I am going to solve this question by the implicit function concept. So let's start. So this is the equation. What I'll do is I'll rewrite this equation as now. We'll start with one term. So first we'll find out the value of del u by del x. Now guys, since this is the implicit function, to get the solution we have 2 methods. Either use the formula method or differentiate each term and get the answer. So I'm going to use the second method. So here I'm going to differentiate each and every term. So del u by del x, to get this value, what I'll do is I will differentiate this equation or each and every term with respect to x. So let's start. So here, if you observe the first term, then in numerator you have x, in the denominator you have u, which is also a function of x. It means you have x in numerator as well as in denominator. So here, to get the answer, what we'll do is we will apply u by v rule of derivative. So by using that rule, here we will get in the denominator a square plus u the whole square. So denominator we get v square, in numerator we'll get a square plus u into derivative of this term, which is 2x, minus x square into derivative of this term, so 0. So here you will get ux. So you can call it as del u by del x, or I'm calling it as ux. So it is one and the same. Next, here I'll differentiate second term with respect to x partially. So now in numerator there is no x term, so this is y square, which is constant, will come outside, and derivative of 1 upon b square plus u is -1 upon b square plus u the whole square into derivative of u, that is ux. And guys, this y square is also there. Next, for third term, again we'll get this z square constant, and I'll differentiate this 1 upon c square plus u with respect to x. So here we'll get -1 upon c square plus u the whole square into ux. So what I did is I have differentiated this whole equation with respect to x partially. For 1 it is 0 and right hand side is equal to 0. Now guys, what we'll do is we will take all ux terms together and non-ux terms together. So here I'll divide these 2 terms by a square plus u the whole square. So if I divide this first term, then a square plus u and a square plus u, 1 a square plus u will be cancelled. Here we'll get 2x and here we'll get a square plus u. So here I'll write, so therefore 2x upon a square plus u. Next, If I divide the second term, I'll get x square ux upon a square plus u the whole square, and that to negative. And guys, if you observe, then similar term I'm getting here and here, which is negative y square b square plus u the whole square ux, and negative z square c square plus u the whole square ux. It means from these three terms I can take ux common, I'll take negative sign outside, and remaining terms I'll write inside the bracket. So here I'll say it is negative inside the bracket x square upon a square plus u the whole square plus y square upon b square plus u the whole square plus z square upon. So now here we got the value in the bracket and ux outside the bracket. So what it will do is, for simplicity or the calculation purpose, guys, I'll take this bracket as some variable. Now why I'm doing this? The reason is, if you observe this result, then here we have to find out square of each term. Now just imagine that if I find the square of this term, then these are already 3 terms and square of that will be around 6 terms. So instead of increasing the terms, let's assume it at some variable and get the solution. So here I'll assume this as f. So this will become therefore 2x upon a square plus u minus f ux is equal to 0, where I would say f is equal to x square upon now here I'll say therefore this will become positive on the right hand side. So f into ux is equal to 2x upon a square plus u. So guys, here we also have f. Now I'll send that f on the RHS and that will come in the denominator here. So it means here we got the value of ux, and that is nothing but del u by del x. So I got the first value. Now guys, we can square this value as we want square, or what we'll do is we'll find out all 3 values and then we'll square the values inside the result itself. Now I got del u by del x. Now I'll find out del u by del y, and for that again I'll differentiate this equation with respect to y. Now guys, let's observe what will be the changes if I differentiate the same equation with respect to y. So the same thing is, the first term and third term is having x square and z square in the numerator. So here we'll get the differentiation as x square, and the derivative of this 1 upon a square plus u will be negative 1 upon a square plus u the whole square, so which will be similar to this, and here you will get uy. Similarly, if I differentiate this term with respect to y, then z square will remain constant, and here we'll get derivative as negative 1 upon c square plus u the whole square into uy, so which is similar to this. And for middle term, again you will apply u upon v rule like this term. It means we are getting the similar terms which we got for del u by del x. So what it will do is, instead of solving it again and again, we can directly write down the result by looking at the previous result. So here we will say therefore uy is equal to, so guys, here as we got 2x, when we differentiated with respect to x, here we will get 2y. In the denominator, here we got a square plus u with 2x. Similarly, here we will get b square plus u into f as it is, and then we'll get the value of uz as 2z upon c square plus u into f. So guys, here we got the value of del u by del x, del u by del y, and del u by del z. Now we'll put all these values in LHS. So let's start. So here I'll say therefore LHS is equal to, so the first term is del u by del x the whole square. So let's square this term. So this will be 4x square upon a square plus u the whole square into f square. Here I'll write plus, here the second term is del u by del y the whole square, and third term is del u by del z the whole square. So we'll square this term, which is 4y square b square plus u the whole square f square, and square of this. So we'll get now guys, let's take common terms outside the bracket. So here I can take 4 outside, and from here I can take f square outside from the denominator, and we'll write down the remaining terms in the bracket. So here we will get x square upon a square plus u the whole square. Then we will get plus y square upon b square plus u the whole square plus z square upon c square plus u the whole square. Now guys, if you observe this bracket, then it is matching with one value which we got here, and that is nothing but the value of f. So we can say that this bracket is nothing but f. So this will be 4 upon f square into f, and by cancelling f and f we will get 4 upon f. So guys, this is the left hand side. Now let's find out the right hand side. So right hand side is this. So let's start. So here I'll say RHS is equal to, so 2 outside. Let's see what we get in bracket. So first term is x into del u by del x, then y into del u by del y, and z into del u by del z. So let's start. So guys, this is the value of del u by del x. If I multiply this with x, here I'll get 2x square. I'll write down 2x square upon a square plus u into f. Similarly, for second term we'll multiply with y. We'll get 2y square upon b square plus u into f plus, now guys, from here we can take 2 common. So if 2 comes out, it becomes 4, and I can take f common. And now in the bracket, what we'll get? We'll get x square upon a square plus u plus y square upon b square plus u plus z square upon c square plus u. And guys, that is nothing but the value which is given in the question. So let's see the question. See, this is the value given, and for which the answer is 1. So we can say that this into 1. So the answer is 4 by f. And now you can see that I have proved that the value of LHS and RHS are equal. And here we get the solution. So I'm sure you understood the method how I got the solution. And guys, in the next video we are going to learn again one more problem on implicit function, and that problem is again the tougher problem than this question, and let's see how to get the solution of that question by using implicit function. Thank you very much.